Hello and welcome to this tutorial on the Unity UI system. Today we will go over the basic idea of the Unity UI, how it works, and how to position basic elements. We will create this text box here with some blind text that I just copied over from the documentation, and also a little hard visualization for the lives in the 2D platformer project that we made in the earlier tutorial series. So we will not deal with any interaction, that is for the following video. Today we simply look at how to position, size and scale UI elements and make sure that they fit with the screen resolution and screen aspect ratio that you want for your game. Adding a UI element is actually quite simple. All that you have to do is right click in your hierarchy, say UI and add, for example, an image. And now you have a new image on the UI. You can see here that it is a child of a canvas element. If you don't already have a canvas element in the scene, it's going to create one, and the canvas is the basic drawing platform for any UI. If we look at the canvas in our scene view, it is actually quite odd what we can see. The canvas is huge in the scene, and our game is all the way down here, tiny, and the canvas is this huge block that we can see here. To understand why the designers of the Unity engine decided to visualize it like this, we have to understand the basic principle behind the canvas. The main difference is that positioning does not involve any units, instead it involves pixels. So any kind of canvas element is positioned based on screen pixels. Basic game elements are positioned in our game world, and how much of them we can see inside the screen depends on, for example, the size of our camera, so the orthographic size, the scale of it, and the position of the camera. So while the camera moves to follow our game objects around, or the main character in this case, the UI will always stay at the same position on the screen. So any kind of UI elements will be positioned based on their settings in the canvas and the pixel size of your screen resolution. So the best way to visualize it is to think of the canvas as a completely separate space that has nothing to do with your game and your scene, and it just happens to be edited in the same window. Before we start editing and creating a UI, a quick mention of the source. Here, the cute cartoon mobile GUI I got from the Unity Asset Store. It's free to download. The UI for the 2D platformer game I made in pixel art, which is a nice small pixel editor to create pixel assets. So let's start in a blank scene so I can show you how to create the text box example that we just saw and talk a bit about how to position UI elements and how to relate their size and shape to each other. If you have ever done any web development and messed around with HTML, some of these concepts might seem familiar to you. So let's create our canvas. Just right click UI and create a new canvas. And it will also create an event system for us. If we do that, the event system, we don't need that. That is for UI interaction, buttons and clicking and stuff like that. I now created a new image element on the canvas simply by right clicking here UI image, and I gave it the panel background for our text box. Besides having the image element to be able to draw the image, we have a canvas renderer component here on it and a rect transform. The rect transform is a special transform component that allows UI positioning. So besides the rotation and scale of the element, we can modify its position with height, anchors and pivot. And here you can see that the width and height is set to 300, which would be gigantic in the regular context of a game scene, of course, but we are working with pixels here. So the width means 300 pixels in width and 300 pixels in height. That again means that this element's size, of course, is going to depend on the resolution of your screen. So if I take the game view here and just plug it out so I can resize it, can see how our element is not going to cover the whole screen, or is actually covering the whole screen depending on the size and the resolution of our game window. You can also see how the canvas actually resizes with me resizing and changing the aspect ratio of our game window. Besides the width and height respective to the screen resolution, we will have to deal with the anchors. Observe what happens if I put my element here to the top left, like we saw with the hearts panel in the 2D platformer. So it is covering the top left of the screen. But now I resize the screen. You can see how the element is no longer on the top left where I want it to be. So we will have to correctly set our UI anchor point that tells the element to which kind of corner of the screen respectively it has to be positioned. So when developing UI, it is extremely important that you are aware of your target resolution and the target aspect ratios on the devices where you want your game to be played. You can set these here in the game view on the aspect ratio panel, for example for full HD or 4K, and you can add your own resolutions here if you want to target anything else. So make sure that you test your UI setup on all possible resolutions that you think your game is going to be played in, and make sure that it looks good on all of them. Of course, there's ways to automatically let your UI rescale and fit the target resolution of different kinds of screens. But before we look into that, let's actually set up a small UI here for ourselves to play around with. Let's start by setting up our text box. I have changed the layout here to something that allows us to see the game view and the scene view simultaneously in a good size. And first we want to add our anchor points, or set the anchor points to some good values. You can modify the anchor points of your UI element by dragging these transparent arrows here around, or by setting values here in the inspector, or even choosing some predefined settings from this box over here. All UI elements are always positioned relative to the box size of their parent. The master parent is our canvas box, and then we can define the position of our image element here based on the box size of the parent or its own pixel size. So we can position elements relative to their parent or in absolute pixel values. Now, if you want to position something relative to the parent, you need to use the anchor points. So let's say I want my image here to cover 80% of the width and height of the parent. I would set my anchors here to stretch from 0.1 to 0.9. So from 10 to 90% of the width and 10 to 90% of the height. Now see how the rect transform changed. So instead of a pixel width and height, I get offsets from left, top, right, and bottom. So if I change these to be 0, you can see now how the UI stretches, the image stretches to cover 80% of the width and height. So if I change my screen resolution now, the canvas size changes, of course, but on the UI there is no change because the positioning and size is relative to the canvas size. I can also set up the background image here to have a fixed pixel width but a relative height. For this I would take my anchors and I can use the simple editor here and center them like so and stretch them so they are covering all from the top to the bottom. And now you can see how the display changed, so I can get an X position and a width, but I still have top and bottom offsets from the anchor points. So if I set my width to be 400 here, and let's say we want 200 offset from the top and 100 pixels from the bottom, and now I resize my screen, you can see how we are stretching on the y-axis, but we have a fixed pixel size on the x-axis. So the image that we positioned here, that should be our text panel. So I renamed that. And then let's have a look at the border around it. And you can see how it sort of ugly stretches here on the top. We can make it actually have the border in a nice way all around. by setting the image type to sliced. What this does is that it, instead of simply taking one whole image and stretching it to fit whatever area it's supposed to cover on the canvas, to instead use 9 separate images which are sliced from the source. So if we look at the original sprite in the sprite editor, you can see how it has these green lines here, and those are slicing the image into 9 sections. We have the center section, and then one for the top left corner, for the top middle, for the right left corner, top right corner, and so forth. So the sliced image type is great for any kind of box backgrounds of boxes of various sizes. So you don't need to have separate images for every kind of different box size that you want on your UI. So next, let's add our header. I put in a new image and I set this image type to be simple because I don't want it to be sliced. It's not a rectangular shape that's easily sliced. So we just gonna stretch it a little bit. And instead of dragging it up here and then sort of rescaling it to fit the top, we have to, of course, also watch our anchor points, because if I do this now and then resize the screen, you can see how it's all screwed up. So we have to position it relative to the canvas scale and width to have it always stay at the right kind of position on the top of the panel. There's different ways on how to do this, but one, for example, is to set the anchor points to the top center. Then make sure that we have the correct position offset from the top, which is equal to the top offset of our text panel. So that would be -200 downwards from the anchor points. Then the same width as our text panel, and the position X should be 0, so we are in the middle. And now you can see if I change my resolution around here, the header stays nice and equal at the top of the text panel. Let's add a background next. So I go again, make a UI image here, call this background. And now I'm adding the background sprite to that. And in order to make it fill the entire screen always, I can simply stretch the anchors to all the edges, like this. And you can actually, instead of having to type in all the values here for the position, simply hold the Alt key and then click again, and it will set the position to where the anchor points are. Well, now my background is in front of my text panel, and actually the canvas sorts its drawing order based on the order that the elements are in the hierarchy. So if I drag my background here to the top, it is going to be rendered first behind the text panel and the header. Last thing now is to add the text. So for our header, I simply add a new UI element text here as a child. Then you can add in whatever text you want here in the text panel. Maybe choose a bigger font size, something that fits nicely. And now to position our text box, I wouldn't just want to drag this like so to fit it. Now, maybe I want my text to be in the center, so I would choose a different text alignment. So this is a bad idea because the size of our text box here, of the header, might actually change with different screen resolutions. So instead we should also modify our anchor points to cover the percentage area that this text header box would fill. So now, whatever size our header has, right, our text box always fills the right kind of area inside this yellow rectangle. The text element fully supports rich text formatting. So for example, I could simply make this text here bold, like so. And I can choose a different font, something more fancy, and mess around it just like any other sophisticated text editor. So let's add the last part to it. That would be the text element here for our text panel. Also here, I would use the anchor elements to position, so I can use the editor the box editor here to stretch the element out to fully cover its parent. And then I maybe want some offset left and right and a bit more on the top because we have the header here and some at the bottom too. Then we will add some blind text. I'll just use the Unity documentation, which is actually extremely good on the UI, especially when it comes, for example, to auto layout elements. So if you want to look into that, for example, how to make a grid system, this is an excellent source to gain information on how to do that. So I'm just going to copy this text and paste that into my text element. Now I can see some of the text behavior. We have horizontal overflow and vertical overflow since our text is longer than the text element can actually display. So if I set the vertical overflow to, for example, just overflow as well, the text element would just go on. So truncate would cut it off where there is too much. But also for things like this, the Unity UI has a solution. Here we have an integrated scroll system called the scroll view, where we can insert any kind of element that is oversized, and it will simply scroll through a mask. So we have the ability to show bigger elements than the UI can cover by scrolling through them with our scroll bar here. That covers basic positioning and sorting of UI elements. So how do we fix the UI to certain positions on the screen? How do we use the anchor points to position them and the pixel offsets? Let's now look at how to make a pixel art UI in our 2D platformer. Here we have a bit of a special case, because our UI elements are in pixel art, so they have extremely small resolution, here 16 by 16 pixels or 24 by 24 for the panel. So we have to set up our UI to accommodate these very low pixel art resolutions. First, let's have a quick look at the setup of the hearts panel here. You can see that the position X and Y is 0 and 0 because the pivot is on the top left corner, together with the anchor points, so the panel is anchored on the top left, and whatever kind of screen size or resolution we would have, it would always be anchored to the top left. Then the hearts are simply positioned inside the element with the anchor point to the left, and then gradually shifted to the right for each heart. We can also see that the size, the height and width of the hearts panel is actually quite small. It's 88 by 24 pixels. So that would be extremely tiny on a high definition screen. However, the hearts panel is shown much bigger because we make use of the canvas scaler element here. The canvas scaler is by default attached to your canvas element, and it allows you to set up a fixed resolution for the canvas that then would be, well, scaled to fit whatever screen resolution you have in the end. So here we set it to 256 by 160 pixels, which actually fits the pixel perfect camera that we set up in the other tutorial. So the pixel perfect camera and the canvas element have the same resolution to fit the exact pixel size of our game. I then set it up to match the height of the screen. So the width would scale and wouldn't exactly be 256 pixel always. It depends a bit on what kind of aspect ratio we have, right? But setting up the UI like this will make sure, for example, in this pixel art setup, that the UI pixel size fits the game pixel size exactly. The canvas scaler is overall a quite useful element also in our different example here. If I set this to scale with screen size and, for example, just type in the HD resolution 1080 and match with the height, I can change my resolution and the UI always stays the same size. It simply gets scaled up by whatever resolution we actually have on the screen. So this way you can also avoid having to mess around a lot with the UI, and you can always have the exact same UI scale no matter what kind of resolution we are working with. But in the end, UI setup is very circumstantial and it very much depends on your needs and the setup of your project. But now you have some tools at your disposal to mess around with to try out what kind of setup fits you best. So let's quickly sum up what we talked about here. We learned the basic UI system, the canvas as a root element of all UI elements being sorted by their order in the hierarchy, the positioning always depending on the parent rectangle, with the rect transform offering you the modification of anchors and position or offsets to the top and bottom depending on how the anchors are set. Then we talked about how images can be sliced into 9 partitions. So when the image type is set to sliced, they will take the corner pieces aside and the top and bottom pieces and stretch them out so you have non-deformed corners on your UI panels. And we talked about how to use the canvas scaler to scale any kind of resolution that you want for your canvas to have in-game to any kind of screen resolution that the final game is going to run in.